Okay, so the other day we stopped at this question and I said that I wanted to do the construct number 7 onwards lah. Okay, so when we talk about the construct number 7, it's very important for us to know what we think, what question is going to be number 7. So 1, 2, 3, 4, 5, 6 we've done, 5 and 6, 5 and 6. 5 and 6 is 5 and 6 is soalan yang membandingkan, and then after that is making relations. Okay, we are expecting that question for structure. And for 7, we are thinking that it is a making choice question, and then for number 8 is the one that untuk bentuk sendiri. Okay, so 7 dia mirip kepada soalan bahagian B, and then 8 is mirip kepada soalan bahagian C. We are assuming that this is going to happen. Okay, so quite a few modules and papers, trial papers that you will see, okay, really go along that line. Okay, all right. So let's begin. Try to answer as many as you can today, and then we finish up tomorrow. Today and tomorrow will be the last 2. And then after that, I'll see you all next year. Hopefully. Okay, hopefully. All right, so diagram 10.1 shows a tool, okay, which consists of a concave mirror, okay, that is used by a dentist to see the teeth of a patient. Okay, so first thing we need to know is, of course, difference between concave and convex mirror, which is entirely different from the concave and convex lens. Okay, so lens, concave, convex is this way, concave, okay, it's this way. Okay, but mirror dia sebelah saja kan. So convex mirror dia akan keluar sama seperti this side of the convex lens. Kan dia akan keluar. Manakala if it is concave mirror, which is the one that we're having now, concave, okay, it will go in like this. Okay. It will be like this. So this is the back of the mirror. It's the back of the mirror. It follows the shape of the concave lens. Okay, something like that. So, and convex mirror is, dia keluar besar. So usually when we talk about convex mirror, okay, it has a, it magnifies, okay, the tujuan lah, okay, adalah untuk membesarkan, tetapi smaller field of vision. Manakala concave mirror dia masuk ke dalam, okay, so it doesn't magnify, it has a wider field of vision. Means you can see more. Hold on, I may be getting this wrong. You can see more if it is a concave mirror. Yeah, okay, there's a wider field of vision. Okay. So the light phenomenon which occurs in the concave mirror, this is very normal. Okay, this is reflection. Okay, definitely reflection because mirror. If it is lens, okay, if it is lens, it's refraction. Okay, so mirror is reflection. Okay, same as the mirror on your wall. Okay, it's all, reflected. Okay, so complete the ray diagram to show how the image of the object is formed. So the object is here. The normal two are straight. Okay, the first one is straight and then passing through F, but it has to be reflected, so it will pass through F this way. So this is the first one. Okay, straight passing through F, and then the second one is from the object head passes through C. Okay, passes through C again, and then these two. Sorry, this is very horrendous drawing. These two will somehow join somewhere at the back here, okay, and will form a virtual image, which is at the back of the mirror. Okay, so we find that this is a 3-mark question. So one, of course, when you do a ray diagram, don't forget to draw the lines and also include the arrows. And because this is a mirror, so there must be one arrow going towards the mirror and another arrow going away from the mirror. So that's why this red line, that's one towards and one away. The green one is towards and away. And then the third mark, okay, so this one mark, this one mark. The third mark is where you draw the object. Okay, that's how you will get the third mark. Okay. So the first line is the red color one, okay, goes dia straight and then pergi ke F. And the second one is dari atas dia melalui C. This is very standard now, no matter where the object is. If the object is here, for example, okay, let's say the object is here, okay, it's still the same. It will be straight towards F, that's one, okay, and then the second one will be directly towards C, okay, straight towards C, and somehow they will form an image at the back here lah. Okay, they are kind of. But for mirror image that is lesser than the focal length, okay, the image will be virtual, okay, at the back of the mirror. Okay, so in this question, they don't ask for the characteristics of the image lah. Dia tidak minta ciri-ciri image. Okay, but in case they do ask, okay, you need to remember that when we talk about the characteristics of the image, there has to be, you have to mention three lah. Okay, either it is virtual or it is real. Okay, either it is upright or it is what is song inverted. Okay, and then either it is smaller or bigger, oh no, magnified. Okay, smaller, not smaller lah, diminished actually, diminished. Okay, magnified or same size. Okay, so you will have to definitely give 1, 2, and 3. Okay, sometimes they only give 1 mark for this kind of question, like characteristics of image. They only give 1 mark. But I have seen marking schemes when even though it's 1 mark, they still ask for all 3 characteristics. So it's very important that number 1, you read the question now. How many characteristics does the question want? Number 2, if they don't specify the characteristics, better you give all 3. Is it virtual or is it real? Okay, so for mirror, if the image is behind here, this is a virtual image. Kalau real, dia berada di sini. Okay, upright means dia sama arah dengan object. So let's see, in this case, our image is here, right? This is our image. So since the image and the object are in the same direction, so it is upright. Kalau katakan ini adalah dia punya image, this is inverted. Okay, so it can be real and inverted, it can be virtual and inverted now. I'm just saying that you don't have to choose green or blue now. Okay, I'm saying every line is different. Okay, number 3, is it diminished, magnified, or same size? In this case over here, it is magnified because this is the height of the object. Ini je the object, but the image is so much bigger than the object. Okay, so is this what you did? Okay, so it is magnified. So in our case over here, this image, okay, the one that we've just drawn over here, this is virtual, magnified, and upright. Okay, virtual, upright, and magnified. So look at the position of the look at the position of the image. Okay, look at the size of the image. It will tell you what the characteristics are. Structure of a parabolic solar cooker. Okay, so parabolic is this shape yang bentuk mangkuk macam ni. That's called a parabolic shape. Okay, and so the parabolic shape of the solar cooker. So you put the solar cooker somehow. Okay, actually this is a passive question. I remember this being a passive, but not solar cooker lah. It's more on the astro dish. It's more on the astro dish thing. But the idea is still the same. Anything to do with the parabola, okay, the basics or the fundamentals behind the parabola thing is still very much the same. Okay, so you have this table, shows you the different positions of where this cooking pot should be, okay, and the size of the aperture. So they give you very little choices in question 7 because it is macam pengenalan kepada section B, which has more choices and more marks, definitely. But the idea is still the same. No. The idea is still the same. Okay, you still have to analyze the table or the pictures depending on what they give you. Analyze this one, okay, the table, and then after that make the choice. Same principle as we do for section B. Okay, now in terms of the position of the cooking pot, okay, it's either at the focal point or less than the focal point. Okay, and actually, this is a giveaway. Okay, because the name focal point means that, okay, so if this is a solar oven, okay, I'm going to draw this sideways macam ni. So any parabolic surface, any mirror surface, bila cahaya masukkan, dia akan terpantul. Okay, and in any normal mirror that we studied, any normal mirror, okay, if this is the focal point, when the light reflects, okay, it will always reflect towards the focal point. It must always reflect. Thank you for the Christmas. Thank you. Okay, so it must always reflect towards the focal point. That's a very important thing about mirror. Curved mirror lah. Okay, it must always reflect towards the focal point. Okay, so by that definition, if let's say I put this one in the sun, the point of putting the solar cooker in the sun is to cook the food using sunlight, using the heat from the sun. So you definitely want to position the pot, you definitely want to position the pot in a place where it's going to receive the most sun. And you want to position the sun in a place where it receives the most sun. That's the most important thing. Okay, so you want to position it in the place where it receives the most sun, so that when it is, so kalau sini adalah dia punya jarak fokus, okay, so dia datang sini and dia akan semua terpantul sini. Okay, light comes here and it's going to reflect over here. So that way, by positioning it at the focal point, okay, you're going to get the most amount of sun. Because if you put less than the focal point, it's only going to get some. If you put more than the focal point, it's also going to get less sun. Okay, so the idea about the reflector is that there is this sweet spot now. Okay, there is this sweet spot where it's going to receive the most light and the most sun. And that point and that sweet spot is called the focal length. Okay, the focal length. So we want to position it at the point after the sun. Okay. Secondly, the size of the aperture of the reflector. Okay, there's only two choices, either big or small. But this is also very logical. Okay, think about mirror. Do you want a big mirror or small mirror? What is the difference between a big mirror and small mirror? Okay, when you have a big mirror, okay, you are going to be able to reflect more sun. If your mirror is so tiny and so kecil, okay, you're going to get the amount of sun you're going to get reflected is only as big as the mirror. So you need a mirror that is big so you can get more light will be able to reflect. So when you analyze this table, you find that, oh, okay, K is the one that I need to choose because K has both. Okay, then only you answer the question. Okay, this is how I will usually approach this kind of question. I make all the choices first, then I answer the questions berdasarkan apa yang saya sudah pilih. Okay, don't go and look into the question then. No, just analyze the table first. The table is always there for you to analyze. So the position of the cooking pot, you can directly copy from here at the focal point of the reflector. Okay, I'm going to this one. And then the reason for this, okay, the reason for this will be the heat, okay, will be focused at the focal point. Okay, the heat will be focused at the focal point. Because if it is more than the focal point, if it is less than focal point, it's not the focal point. Okay, the focal point is where everything converges. Okay, semua berjumpa di tempat yang sama. Okay, so the heat will be focused at that focal point. The size of the aperture, the answer is given here, is big. Okay, so you just write big. Okay, no need to write full sentence. Okay, and then the normal reason for the size of the aperture will be more heat can be reflected. Okay, more heat can be reflected. You can also say more light lah, because either way, light and heat, it's kind of the same idea lah. Okay. So even here, if you say light and heat, also, I don't think it's a problem because the light is the one that actually contributes to the heat lah. Okay, and finally, based on your answer in 10B, which is the best solar cooker, we have already established this. This will be solar cooker. Okay. The question doesn't ask for a reason, just ask for which one only, and it is only 1 mark. I have during the trials, quite a lot of you're okay because then you write the whole thing again. Okay, sampai 2-3 baris. No need lah, no need. This is a structure question. Structure questions are just like introductions to the essay questions. Okay, so don't overthink this lah. Structure is very simple. Okay. Diagram 11.1 shows a spacecraft orbiting around the Earth. Okay, so this is obviously chapter 3. Okay, chapter 3 in Form 4, gravitation. Everybody's favorite chapter. Okay, so name the force that enables the spacecraft to stay in its circular orbit. I think we did a question similar to this in our trials, and a lot of you put gravitational force. Actually, it's not true, The gravitational force provides the centripetal force. Okay, the centripetal force is the one that enables the spacecraft to move to orbit. Okay, so the key word to this is this: to stay in its circular orbit is the centripetal force. Okay, those of you who are in SA, you will remember last year I asked you to do the demonstration, right, with the pen and then with the plasticine, then you twirl around, right? So the thing is able to stay on a circular orbit because of a centripetal force. But the centripetal force, okay, is provided, or say what provides the force? By the gravitational force. Okay. The gravitational force is only one way, towards the center of the Earth. So here. Okay, so the gravitational force provides the centripetal force that causes the thing to orbit. Okay, harus dibezakan lah antara these two. What is the centripetal? What is the gravitational? Okay, very important. All right, at what height should the spacecraft from the surface of, should the spacecraft be from the surface of the Earth if the spacecraft is required to orbit the Earth in a period of 24 hours? Okay, so question is asking for height, which is, oh no. Okay, hold on. Oh no. Which is this, hold on. Okay. You want to know this height. Okay, you want to know the height of the spacecraft. But the only thing they give you is the period. Okay, and in the entire Form 4, Chapter 3, there's only one formula that connects the height with the period, which is Kepler's third law of linear formula. Okay, so it is T squared equals to 4 pi squared over GM R cubed. Okay, this is this one lah. Okay, except that the R, okay, the R is a very important thing. I remember all the R's in chapter 3, Form 4 is from the center of the Earth to the object. So this whole thing is the R. So when you calculate this, okay, and I would want you to do this on your own, okay, you can leave the period as it is. I think that's not a problem. Just put 24 equals to this one. Okay, what you will get now, when you get this R, okay, remember that you need to minus, okay, the R will be minus the radius of the Earth, okay, to get the height, which is this one. The height is the one that we want. So please remember this. Okay, so once you calculate the R, you need to minus the radius of the Earth, because remember all R's in all the gravitational formulas starts from the center of the Earth until, whatever is on the other side lah. Okay, so you minus the radius of the Earth. You will have to check what is the radius of the Earth in the formula lah. Like, I don't really remember at this point. Okay, but just remember this one. But let me give you the answer. The answer is h equals to 3.59 times 10 to the power 7 meters. Okay, this would be the answer. 3.59 times 10 to the power 7. That's the answer. Okay, same thing, making a choice. Okay, let's look at the question first. Space agency wishes to launch an imaging satellite that is able to capture the images of various locations, okay, on the surface of the Earth. On the surface of the Earth. So based on table 11, okay, let's look. Orbital period. You want to be able to capture at different locations. So the orbital period cannot be 24 hours, because if it is 24 hours, it will be a GEO satellite, geostationary Earth orbit. Okay. Oh, sorry, it will be a geostationary, sorry. Geostationary. Okay, satellite, which you don't want, because we want to go at different places at different times. So the orbital period has to be less than 24 hours. Either less than 24 hours. Okay. So there's only one there's only one that allows that for that to happen, which is this lah. Can't be the 24 because we don't want the 24, and it can't be more, because if it is more, it's not going to be able to go fast enough to take pictures of different locations at one time. So you want it to be less. Okay. Now, second one is the height. Do we want a higher height or a smaller height? Do we want a higher height or smaller height? Hold on. Do we want a higher height or smaller height? Oh, we need a smaller height. It's very interesting. Okay, we want a smaller height. Okay, we want a smaller height because the higher your height is, the more difficult it is to get a clearer picture. It's very logical. Right? The higher your height is, because you want to take photos of the Earth. You're not going to take photos of space. You want to take photos of the Earth. So you want to be as near as possible to the Earth. Bye-bye. Okay, you want to be as near as possible to the Earth. Okay, of course, without crashing into the Earth, but you want to be as near as possible to the Earth so that you can take more clearer pictures. Okay, but this presents, now if you look at our analysis, this presents a problem. This presents a problem because in terms of orbital period, R is the best. But in terms of the height of the orbit, P is the best, is the smallest. So what do we do in situations like this? And this has happened before. Okay, I'm telling you this, and this has happened before. In trial papers, I've seen this in SPM. I think it did lah. It has happened before in SPM. You know, they give it's not very clear cut, and you have to make an extra decision on top of that. Okay, if this happens to you lah, okay, if this happens to you, you need to make a choice. You obviously have to make a choice. Okay, but the idea is the same. The orbital period cannot be 24 hours. Otherwise, it's going to be geostationary. Okay, but best case scenario is orbital period is less than 24 hours. That's the best case scenario. But in this case, we cannot choose one that has this one because the height of the orbit is too high. It's too high for, for a clearer image. Okay. At the same time, we also have to think about the ketinggian orbit tersebut. Okay. 4.3 is very nice. It's very low and it's good enough to take clearer pictures. But the orbital period is the same as the Earth, which cannot be. So when this happens, you have to take the middle road. Okay. Yes, I know the orbital period is not ideal. It is not less than 24 hours. It is actually more. Okay. But even with a big orbital period, now you can still take images at different locations. Okay. Secondly, the height, yes, it is not as low as 4.3, but it is not as high as 7.6. So sometimes, really taking the middle road is kind of like the best choice. But you don't change. Okay, so this is the thing. So when we say the tempo orbital, the orbital period now, we don't give numbers. Okay, so this is another thing we need to remember. When making a choice, We always say we want a high orbital period or low orbital period. We don't give a specific number because, okay, what happens if we give a specific number? Let's say I write here 1.52, and then over here I write 4.3 times 10 to the power of 7. Then what is the best choice? You can't answer that question anymore because you've already given the number that you want. Sorry, I'm going to change this to the power of 7 now. It cannot be to the power of 3. The power is too small, too near to the earth already. Okay, to the power. No, it's too small. Okay, to the power of 3. Yeah, to the power of 3 macam kamu belum lagi melepasi our atmosphere. It has to be power of 7. Then, yeah. Okay. Sorry, yeah. sorry. Okay, so okay, it's definitely not to the power of 3 lah. Okay, to the power of 3, kita belum lagi melepasi atmosphere. We're still in our atmosphere. Definitely, there's no satellite there lah. Okay, I'm going to keep it to the power of 7 now. So again, if let's say you give the answer, okay, 1.52 and 4.3, then you cannot answer this question at DD because you know, you cannot make a choice. One is P and the other one is R. So we want to make a middle choice. And this has happened before. Okay, that's why we always advise students, we say, okay, the orbital period must be smaller than 24 hours. Okay? Orbital period or smaller or actually bigger also can lah. Okay, so the reason is can be at different locations at different times. Okay, can be at different locations at different times. The idea behind less or more than 24 hours is this lah. It doesn't have to be in the same position only, because if it is the same position, if it is same as 24 hours, it's just going to follow the same position. But higher or smaller, of course the best is smaller. Higher or lower, okay, it will be at different positions at different times, which is what we want. Okay, then the height of the orbit, okay, we want the height of the orbit to be small. Okay, we want the height of the orbit to be small to be able to take clearer photos. Okay. Able to take clearer photos. Okay, that's the idea behind that. So when you answer like this, then you give yourself some room to be able to make better choices, especially when the choice is not as clear-cut as this. Okay, so this one will give us the choice Q. Because of all the three, Q is like the middle road lah, that you have to take sometimes. Okay, so this is a good question now for me to demonstrate to you that sometimes, I'm not saying every time this is going to happen, but we need to be aware that sometimes the answer is not very clear-cut. Sometimes you will have to take a middle road. Okay. Yes, it is not less than 24 hours. It is actually more. But the idea is we want to be at different places at different times. Pandai-pandai lah diorang adjust. Because if your orbital period is ngam-ngam 24 hours, you cannot go anywhere. It's just going to orbit. But if it is more than 24 hours or less than 24 hours, which is the best, if it is more than 24 hours, pandai-pandai lah diorang adjust to take photos, whenever they pass that particular place lah. But the one thing that cannot be compromised is the height of the orbit. The height has to be low enough. Okay, and when you think about it, 4.3 and 6.4 times, at 4.3 and 6.4, okay, when you multiply it to the power of 10, to the power of 7, times 10 to the power of 7, that's a very big difference actually. Okay, but 6.4 and 7.6 is also the same. It's also a very big difference. There's 7 zeros behind. So it's a very big difference. Of course, the best is 4.3. But it's 24 hours. You cannot do anything with 24 hours. Okay, so sometimes when you can't have the best, wow, life lesson, you have to settle for the second best. And it's okay. Okay, because ultimately, kehendak soalan itu yang kamu mau penuhi. You fulfill the objective. No point getting the 4.3 if the orbital period is 24 hours. Okay, so the best one to be Q. All right, 12. Diagram 12.1 also same, construct number 7. So we are making a choice again. Okay, shows a current carrying conductor placed in a magnetic field produced by two permanent magnets. So this is chapter 3, 3.1. 4.1, sorry, 4.1. Okay, the elastic, medan elastic field. Okay, so what is the meaning of the magnetic field? Okay, magnetic field is a region which experiences a magnetic force. Okay, and since we're talking about magnetic field, I will also talk about electric field. Okay, electric field is the exact same definition, except that we don't use the word magnetic, we use the word electric. So electric field is a region which experiences an electric force. Okay, dielectric. Okay, diamagnet. So that's called a magnetic field. Now on the on the diagram 12.1, mark the direction of the force acting on the conductor. So this one, okay, is always tied in with this one, name the physics rule. Okay, and if you know your stuff, you will know that the conductor is going to move. Okay, because you provide current. Conductor is going to move. Conductor is going to move is Fleming's. Which one? Left hand or right hand? Okay, it's left hand. Left hand rule. Okay, remember, motor. Okay, conductor moving. Okay, is left hand. Because movement, you're providing a movement. Okay, if it is a generator, okay, or current produced, when you're producing current, okay, this is right hand rule, Fleming's right hand rule, because you are producing current. So remind yourself, left hand is produce movement, right hand is produce current. Okay, so that will help you to decide, because the three fingers are the same, FBI, it's always the same, force, magnetic field, current. Okay, it's just that the different hand tells you the different things that it's producing. Left hand produces movement, right hand produces current. So based on this, okay, so we look at this. Current flows from positive to negative. So this is the positive, so it's going to go inwards. Okay, if you follow the line, it's going to flow here. North is here, south is here. So you position your hand okay, you position your hand in such a way, okay, and you will find that the force is going downwards. Okay, so you mark downwards and the direction with a F. So the conductor is going to move downwards. Okay, now then of course, usually they will also ask you to draw the magnetic field pattern. Now you know that it's going to go downwards. So if it is going to go downwards, where is the elastic going to be? Remember, the elastic field is, if the direction is this side, the elastic field is on the opposite side. Macam kamu main elastic lah. If you want the batu to go forward, you have to pull the elastic backward. So the elastic will be more here. Okay, you draw 3 lines is enough. Draw 1 line at the bottom. Make sure that you draw the field going from U to S. The idea, again, remember, the elastic has to be very clearly shown. Okay, yeah, this is actually better lah. Okay, and then down there is not so elastic. Okay, because kamu tarik elastik ke belakang, kalau lepaskan, daya akan bergerak ke bawah. Okay, so that's how I would draw the elastic force. Okay, as long as you show that there's, and it's especially important that you show 1 line at the bottom to show that there is no elastic field there. The elastic field is on top. Okay, so to show the difference lah. Okay, all right. Now we come to the section C question. Section B question, same thing. Okay, make the choice. 3 electric motors, but instead of giving you a table, they give you different, aspects of it. Okay, they give you different aspects of it. But if you look at the question, there's only the number of turns, the number of batteries. That's all. Okay, so let's take a look. Number of turns is 100, 50, and 50. Okay, so Do we want 100 or 51? Obviously, we want 100 lah, because the more turns you have, okay, the more force is generated, higher the force, okay, because there is more current flowing lah. Okay, how about battery? You have 3 batteries, 1 battery, and 3 batteries. So we obviously want 3 batteries. Okay, we want 3 batteries. Why do we want more batteries? To produce more current. That's very normal, right? To produce more current. Okay, or if you also understand electromagnetism, you will know that the bigger your value of the current, okay, the greater the magnetic field strength lah. Okay, kekuatan medan magnet lebih besar kalau lebih banyak arus mengalir. So that's also a possible answer. So this is more clear cut. If you see, I have circled both in R. And very, very jelas lah. Okay, obviously S tak boleh and T is half can, but not enough turns. Okay, so this is also another way of analyzing the question. Okay, look at the picture, and then after that circle which one that applies to you. Okay, so, but same thing, we don't write the number in the question, in the answer. We write more turns, more number of turns of the coil. Okay, why? To produce a greater force. You can say to produce a greater force. Okay. So again, now we don't write the number. We write more, less, higher, lower, all those things. Okay, don't write the number in case you get yourself stuck in a situation like just now punya question, like, oh no, I put the number already, how? Okay. Number of battery, more number of batteries. Okay, to provide more current. Okay, or if you understand, like I said just now, if you understand the connection between current and magnetic field, okay, stronger magnetic field. You can also say that. Okay, you can say stronger magnetic field. Or magnetic field in strength for the magnetic field increase also can. Okay. So based on your answer, this is very clear cut lah. Okay, we know that the answer is R. And again, because this is a structured question, you don't have to write the reason. Okay, leave the long answers to the essay. Just remember that all the structured questions are like introduction to the essay questions because they're quite similar. Okay, you have all these, definitions in question 1, 2, 3, 4, calculations in question 3 and 4, which appear in the essay questions. Then you have 5 and 6, which is the compare and relate question, which will appear in question number 11, essay. Okay, then you have this one, the making the choice question, which will appear in question 9 and 10. Okay, so it's all related. You just have to know the technique to use, okay, in which part of the paper lah. Okay, structure you do this, but you don't do this. Essay you do the whole thing, okay, from the beginning to the end. So understanding this hopefully, okay, helps you to see the physics paper as like, oh, actually there banyak repeats saja, just that you need to know what the content is lah. Okay, let's go to construct item number 8. Okay, so we are presuming that number 8 questions are going to be the reka bentuk questions lah. Okay, which is when we say reka bentuk means you have to design or you have to make improvements or things like that. Okay, so what is alpha ray? Okay, an alpha ray is a helium nucleus. Okay, that's it. What is beta ray? A beta ray is a fast-moving electron. So beta ray is a fast-moving electron. Okay, a gamma ray, okay, is an electromagnetic wave. Okay, that's gamma ray. Gamma ray is an electromagnetic wave. So you're given this one, given the mass, yada 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 yada. Calculate the mass defect. I don't think they give you. Yeah, they didn't really specify whether it has to be in AMU or kg, but I guess that you need to know both lah. Okay, so this one is pretty simple. You have this one here already, thorium on the left side and radium and alpha on the right side. Okay, so the mass defect, so it will be 230.0331 equals to thorium on the left side, and radium is 226.0254 plus 4.003 plus the mass defect. Because in this equation, what it is not telling you is that there is also energy. Okay, atomic energy lah, or nuclear energy. Okay, so the energy that is produced in a radioactive decay, okay, or any radioactive process, okay, is because of the mass defect. Ada sedikit susutan jising. Okay, so when you calculate this, you find that, oh, yeah lah, actually ada baki pula on the left side and the right side. Okay, so 230.0331 minus 226.0254 minus with 4.003. So you will get mass defect is 4.7 times 10 to the power negative 3 AMU. Okay, 4.7 times 10 to the negative 3 AMU, but you need to change it to kg. So how to change AMU to kg? We just multiply by 1.66 times 10 to the power of negative 27. So times 1.66 times 10 to the power negative 27, you will get 7.802 times 10 negative 30 kg. Okay, yes, negative 30 is a very normal number, so don't worry about it. Okay, because it's just one atom. Okay, it's just one atom punya energy. When you combine all the atoms together, that gives you the big energy. That, okay, but it's just one atom. Okay, in this case, we're only considering one atom, so it's fine for the energy to be, sorry, for the mass defect to be very small, 7.802 times 10 to the power negative 30. But we use that to calculate the nuclear energy using the formula E equals to mc squared. Okay, you are given the value of C, 3 times 10 to the power 8. So when you calculate this, remember this mass has to be in kg, not in AMU. Okay, that's why you have to know how to change AMU to kg. So you will get the answer 7.0218 times 10 to the power of negative 13 joules. Okay, also a very small number, but remember this is just one atom. Okay, 7.0218 times 10 to the power negative 13 is just one atom only. So when you do that with many, many atoms, then you will get a lot of energy. Okay, all right. One agency, a nuclear agency, plans to build a nuclear reactor, gives suggestions. Okay, so this one is question number 8 and also question number 11 are more of, you need to know. Okay, you need to know how to do all this reka bentuk, because there's not really that much clue given except for the characteristics lah. That's it. So if you don't know means you don't know. Okay, if you know means you know lah. And how do you ensure that you know is by practicing a lot more. Okay, answering a lot more questions, and hopefully the questions when you answer, the answers will stick with you and be like, oh yeah, we answered this before. Okay, so answer like this. Okay, material for the coolant. Okay, coolant is penyejuk. Okay, the nuclear reactor needs to cool down, and we use not just water, we use heavy water. It's a very specific answer for a very specific reason. Okay, we use heavy water. We don't just use normal, like, the water that we drink from the tap, but we use heavy water. And the reason for this will be high specific heat capacity. Heavy water has a higher specific heat capacity than normal water. How do they make the water heavy is a part of physics which I have not yet really explored. I remember reading about it, but I can't really remember off the top of my head now. Okay, but I know that heavy water and high specific heat capacity, actually it's higher lah. Okay, specific heat capacity is very, very closely related. Okay, so kita kasih, kaitkan ini dua lah. Okay, the reaction control method. Now there are two. Okay, one is what is the core that you use, and then the other one is what is the metal that you use to this one. So there are two possible answers for this. Number one, either you use boron or cadmium. Sorry, cadmium is C. Okay, either you use boron or cadmium. I'm going to give you the alternative answer in a while. So why do we use boron or cadmium? Okay, is to absorb excess, okay, neutrons. Okay, sebab sometimes you get all these neutron yang berlebihan bahkan. So we want them to be absorbed so that they don't continue the chain reaction. So we use boron or cadmium. Okay, I think this is called control rod. Okay, boron as control rods. Okay, this is one way to control the reaction. Okay, another way to control the reaction is by using a graphite core. Okay, we use the graphite core, okay, is to slow down the neutron movement. Because when you slow down the neutron movement, okay, when you slow down the neutron movement, then it becomes very hard for them to, break the uranium apart. Okay, to set off the chain reaction. Okay, we don't want that. So either one of these two answers is fine. Okay, but since of course we are ulang kajiing, okay, it's important for us to know that there are different reaction control methods. One is to absorb the neutron, and the other one is to slow down the neutron. Okay, so if there's more graphite inside the reactor, then the neutrons will be slower. If you take it out a little bit, then the neutrons can move a bit faster. So we can control the movement, or we can control the number of neutrons. Okay, either way. Okay, so it's good to have this both in mind when you answer this. I think there's one more. Oh no, there's only two. Correct. There's only 9 marks. Sorry. Okay, there's only 9. Okay, so notice in the question 8 question okay, in the structure question 8, it is sama ada kamu tahu atau tidak tahu. Okay, so it's a pretty dangerous question in that sense because there is not really that much clue. Okay, you have to know this, you have to know the modifications, and sometimes, yes, you can tembak sometimes, but there are some situations where you can't tembak, and this is one of them. Okay, this is one of those situations that it's very hard to tembak. It's either you know or you don't know. Okay, because nuclear reactor is very specific. Okay, very specific on this. All right, 14.1 shows a slinky spring move repeatedly. Okay, so what is the type of waves that are produced by the slinky spring? This is obviously, this is a transverse wave. Okay, because the direction of propagation and this is the movement, sorry, the vibration, okay, the vibration of molecules is perpendicular. Okay, so the wave is going up and down, but the wave is also going forward. So that is, sorry, the movement of the wave, the propagation of the wave, okay, is moving forward. So this is a transverse wave. The opposite of a transverse wave is a longitudinal. Okay, longitudinal wave is where if you take the slinky, you bergerak depan belakang, the wave also go depan, the wave goes this way lah, but the vibration is this way. Okay, depan belakang. Now, another possible answer to this, because of your new syllabus, you can also call this a progressive wave. Okay. Progressive wave. The opposite of a progressive wave is opposite. Okay, the opposite of a progressive wave is a stationary wave. Okay, and the best way to show the difference between the progressive and the stationary wave is when you plug a guitar string. Okay, when you plug a guitar string, you produce the sound. So the sound is a progressive wave. The sound from the guitar string is a progressive wave because the bunyi akan sampai ke telinga kamu lah. So obviously it's a progressive, it's a moving wave lah. But the string yang bergetar di tempat sendiri tanpa bergerak, it is not moving, but it is only vibrating up and down without moving forward. That is a stationary wave. So the vibration of the string is a stationary wave, but the sound wave produced by the guitar string is a progressive wave because the wave travels. Okay, in the guitar string, the wave doesn't travel, it's just there only. So that's a stationary wave. Okay, so that's one way of looking at it. And progressive wave and stationary wave, you cannot really say what are the examples. Okay, like I said, the best way to show the difference is the plucking of the guitar string. But transverse wave and longitudinal waves, they are the very common examples. Longitudinal is only one, which is sound wave. Sound wave is a longitudinal wave. Transverse wave is water wave, okay, electromagnetic waves, okay, light waves, okay, and so on and so forth. Okay, so these are transverse wave. They are, because we know our waves are going up and down, but they're also going forward. Okay, but longitudinal, there's only one example, which is sound wave. Okay. If the frequency of the hand movement is 5 Hertz, calculate the speed of the waves. Okay, the formula for this is V equals to F lambda. You are given F, so no problem. But now what is the lambda? Okay, the lambda is definitely not 15, everybody, because how many waves are there? There are 2 waves, 1 and 2. Okay, there are 2 waves in this one. So if 2 waves is 15 cm, the wavelength is the length of 1 wave. So 2 waves is 15, 1 wave will be 15 over 2. So the lambda will be 7.5 cm. 7.5 cm, correct, it's cm lah. Okay, this one will be 5 Hz. So when you calculate this, okay, depending on your preference, you can leave your answer is 37.5 centimeters per second, or kalau kamu mati-mati juga mau meters per second, okay, fine, 0.375 meters per second lah. Either way, doesn't make a difference, as long as you get the unit correct. Okay, if you're going to use cm, state your speed in centimeter per second. Okay, in the past, during the old syllabus punya exam, I would emphasize meters per second, meters per second, meters per second. But these days, they are like, actually it's okay if you use centimeter also, as long as the final unit you write centimeters per second. Okay, be aware of the units that you're using in your calculation, so that when you give the final unit, di dalam jawapan akhir kamu, dia tally. Okay, jangan di atas kau pakai centimeter, tapi sekali di bawah itu jawapan kamu meters per second. It's like, what? Kenapa ini? Okay, jangan juga begitulah. Okay. Alrighty. Hold on. Okay. Slinky is then vibrate at both ends. So that means you have one end over here, and then you vibrate it at the same time. So you kind of know what's going to happen. In diagram 14.2, the pattern of the waves in box X, how would they descend? Okay, so if you think about it, this is a crest, and this is also a crest. So when crest and crest meet, what will happen? They will menjadi 2 kali lebih besar. Okay, they become 2 times of the amplitude, dia akan bertambah. Okay, and why does this? We have constructive interference. Okay, oh sorry. So the crest and crest, bila dia bercampur, dia akan menjadi lebih besar. Okay, because dia berjumpa dengan, and they will be added together lah. Okay, so we call this constructive interference. All right. Okay, now we come to the reka bentuk question. Okay, the design question, the suggestion question. So, question is, shows a beach site that will be turned into a beach resort. Okay, so the question is, give the suitable location. You want to build a beach that is safe, okay? Build a beach that is safe. So where is the location? Secondly, one method to prevent from erosion, and that's it. Okay, there's only 2. Now, the second question seems a bit simpler. Okay, ada banyak cara ni kan untuk menghalang daripada hakisan. Okay, you can actually put anything that you want, but the location is very important. Okay, and if you know that beach, generally there are two locations lah. Either it is at the bay or it is at the cape. Okay, and the very sad part, sorry, the very sad part about this question and Sabahans in general lah, okay, is that we always tend to answer Tanjung or Cape because of Tanjung Aru. Okay, but you need to know that Tanjung Aru is a very huge area, and the actual Tanjung is only a very small part only. Okay, the rest of it actually is a cape. Okay, so actually, sorry, the rest of it actually is a bay. Sebenarnya yang lebih selamat adalah obviously is bay. Okay, it's Teluk. Like for example, Teluk Nikas. Okay, that's a very safe area because the waves are calmer, or you know, the energy of the waves is less. Okay, the energy of the wave is less. Why is this so? Okay, this is another phenomena, refraction. Refraction of waves causes the energy of the waves to be less. Okay, they akan lebih spread out. Okay, so be very careful about this lah. I generally find that people because we're so used to Tanjung Aru, and you know Tanjung Aru there is a very famous hotel there called the Shangri-La Hotel. Everybody thinks that, oh, okay, because Shangri-La is in Tanjung Aru, so the answer must be Tanjung. The answer must be Cape. But no, actually Bay is safer. Bay is way safer, okay, compared to Cape. Cape is a place where you put rumah api. Okay, you put lighthouse on a Cape. Because the function of the lighthouse is to warn people, memberi amaran, oh okay guys, don't come near here, jangan mendekati sini, sebab di sini ada banyak batu. Okay, Cape has a lot of rocks, Bay has a lot of sand. Okay, so it's safer lah. Okay, one method to prevent from erosion, and this can be a various numbers of, you know, of this one. Okay, you can build a strong barrier. Okay, you can build a strong barrier. You can build a high barrier. Okay, or you can build a barrier with a gap. Okay, you put a barrier. Means if let's say this is the beach, you put barrier here lah, with many gaps. Okay, so if it is a strong barrier, this one usually the answer is quite the same lah. Okay, so strong barrier or high barrier, so withstand, okay, wave energy. Okay, dia boleh tahan, you know, kekuatan ombak lah. If you put a barrier with a gap, the answer will be to decrease wave energy by diffraction. Of course, this is a much nicer answer lah. Like, oh, okay, wow, this is a physics answer. You know, you decrease wave energy by using the, you know, the phenomena of diffraction. Okay, that's very good lah. Okay, or the energy of the waves is spread. Sorry, hold on. Okay, decrease wave energy or spread the wave energy. Okay, by diffraction also can. Okay, so that I mean, you know, I wouldn't say that, oh, okay, jawapan di sebelah kiri is a normal answer and jawapan di sebelah kanan is a A+ answer. No lah, it's no such thing as that one lah. Okay, but I mean, you know, obviously the answer on the right, this one, is a more physics answer lah, more physics related answer. This kind of answer, anybody also can give. Okay, anybody also can. It's a logical answer. It's still a logical answer, and anybody also can give. Okay. So much to say that sometimes bila kita menjawabkan, kadang-kala, not always, kadang-kala kita pakai logic saja. As long as you can state the method and you can give a strong reason or good enough reason, the logic will work. Okay, so yeah. Okay, physics paper is designed to help people one. Okay, let me see. All right, let's do one last question, then we'll take a short break now. Okay. So 15.1 shows a convex lens with a focal length of f. Okay, the image produced through one of the light phenomena. Okay, so this is a lens question. So name the light phenomenon that is involved in the formation of the image. Okay, this will be refraction. Okay, we saw this just now in the first question. Mirror is reflection, okay, pantulan, but lens, okay, is refraction. Okay, which is, refraction lah. Okay, so explain how the focal length of the lens can be determined. Okay, so this is a 2-mark question, but actually it can be a 4-mark question. But okay, fine. So the lens, okay, the lens is directed towards an object. Should it be far away? Oh, okay lah. Okay, lens is directed towards an object. Okay, secondly, the screen is moved until, and this is the key word, okay, until a sharp image is formed, okay, on the screen. So you put a lens over here, okay, so the object is from far away, then you move the screen until you see a sharp image on the screen. Okay, then after that, the distance from lens to the screen, okay, is the focal length. Okay, so again, focal length is where all the light meets at that point. So you will get the sharpest image. Whether it is lens or mirror is the same. The focal length is where all the light meets at that point. So the sharpest image will be formed there. The best image will be formed at the focal point. So the distance from the lens to the screen this is what is called the focal length. Okay, if an object is at a distance of 15 centimeters and the focal length is 12 cm. Okay, what is the image distance? This is standard formula. The lens formula is 1 over f equals to 1 over u plus 1 over v. F is the focal length, u is the object distance, okay, which is given already, and v is the image distance. Okay, so at first glance, it's pretty simple because the focal length is given. So 1 over 12 equals to 1 over 15 plus 1 over u, 1 over v, sorry. Okay, 1 over 12 equals to 1 over u, 1 over 15 plus 1 over v. Okay, now I am not really sure why, but I always notice that a lot of students tend to get something wrong with this question, as in they can substitute it correctly, but somehow the calculation always tunggang terbalik on. Like, don't know what happened with the calculation. Okay, so I'm going to show it to you just to make sure that you don't go off track. The first thing is kau pindahkan the 1 over 15 lah. Okay, so it'll be 1 over 12 minus 1 over 15 equals to 1 over v. Okay, then you will get 1 over 12 minus 1 over 15, you get 1 over 60. So 1 over 60 equals to 1 over v. Logically, if 1 over 60 equals to 1 over v, therefore v equals to 60 cm. Done. Okay, it's a very simple calculation, but I'm always amazed at how people can still get this wrong after so long. I mean, like, this is really not maths at all, But let me tell you what I always find a lot of students to do. The first thing they do is they flip the whole thing. 1 over 12 equals to 1 over 15 plus 1 over v. So you know what you do? You know what they do? 12 equals to 15 plus v. Cannot. Okay, my dear friends, this cannot happen. There is a reason why it is 1 over v plus 1 over u. Okay, so I always see this happening. Okay, like kalau macam itu kan, bagus saya tulis f equals to u plus v. But it's not. Okay, the equation is 1 over 1 over F equals to 1 over U plus 1 over V. Okay, that's a very important one. And don't flip it until the end. Okay, only at the end that you flip it. I always see this mistake quite often, actually. Okay, be very careful. Huh? Okay, again, suggestion, telescope. Okay, and because this is a structural question, so they won't really ask that much lah. So we want diameter of the lens and the focal length. Two aspects only. Okay, diameter of the lens and aspect of the lens. The focal length of the lens. So the first one, diameter, is very normal. We want a big diameter. We want a big lens lah. Okay, and why do we want the big lens? So that more light can enter. Or you can get the clearer image. Some people say brighter image also can, yeah. Because the idea of having a big lens as opposed to a small lens is when you have a big lens, more light can come in. When you have a small lens, you know, the amount of light depends on how the amount of light that can be refracted. Depends on the size of the lens. The bigger your lens, the more the light can refract. Kalau kamu punya kanta begini dan kalau aku punya kanta begini, okay, sini kan 3 saja boleh lalu. Sini 1, 2, 3, 4, 5, 6. You have more light can enter, so more light can refract. Sorry, okay, refract and meet. So you know you have a much sharper or clearer image. Not sharper, sorry. You have a much clearer image lah. Dia lebih terang. Okay, so whenever we say the diameter of the lens, and usually they want it in a good way, we always say big lah. Even if you don't know what's the answer, just remember this lah. Diameter of the lens should be big so that more light can enter. Okay, but for telescope, okay, we want a big focal length. Okay, or higher focal length. Focal length that is longer. Okay, so that we can get a bigger image. Okay, we can get a bigger image. Or is it a big, yeah, is it a bigger image? Yeah, it's a bigger image, correct. Okay, yeah, we can get a bigger image if the focal length of the lens of the telescope is bigger. Okay, we can get a bigger image. So diagram 16.1. Now we're going into question number 9. Okay, so again, we're expecting question number 9. This is section B, which is an essay question. Section number 9, we are expecting it to be similar to question number 7, which is the making choice question. Okay, so you answer, then after that, they will give you a table and then you make the choice lah. Okay, so that's a very normal one where we get 10 marks. Okay, so have this in mind. 9 dan 10, 2 soalan, kamu kena pilih 1, and it is a making choice question. And we don't know whether 1 soalan form 4, 1 soalan form 5, atau 2 soalan form 4, atau 2 soalan form 5. It can be either one of these. Okay, so jangan set, okay, saya study form 4 sajalah supaya saya ada chance dalam, no such thing. There's no such thing anymore. It can be both form 4, both form 5, we don't know. Okay, but what we do know is how the questions are going to be structured. Okay, usually there will be a definition question. Okay, so in this case, what is meant by thermal equilibrium? Secondly, there is always an explanation question, which is a 4-mark question. So I will always refer to this as 4-mark question in essay. So 4-mark question is explain this, explain that, you know, so we talk about physics there. And then one of the questions, the 5 marks question for this will be a calculation question. So you expect a calculation question in this section. And then of course, the final one is a 10-mark question. So it's always 1, 4, 5, 1. Even in section C, there's a 1, 4, 5, 1. Pemecahan lah, 1, 4, 5, 1. Cuma dia punya 5 marks itu lain sikit. Okay, we will come to that when we go section C. So be aware of this. Okay, section B is 1, 4, 5, 1. Definition, explanation, calculation, make the choice. 10 marks question. Sorry, 1, 4, 5, 10. Why did I say 1, 4, 5, 1? 1, 4, 5, 10. Okay, 1, 4, 5, 10. So diagram 16.1 shows a metal block M of mass 4 kg at 120 degrees Celsius immersed into a beaker filled with water, 0.2 kg at 30 degrees Celsius. So the water is at 30 degrees Celsius. The metal is at 120 degrees Celsius. So you know what's going to happen. Okay, the heat is going to come out more from M to the water, and some of the heat is going to go into the M. That's very normal. Okay, so that is, and then yada lah. Okay, thermal equilibrium. So this graph shows the temperature against time graph. So we find that at the beginning, the water in the beaker, the temperature will increase lah, and then finally they will reach a steady temperature of 50 degrees Celsius. Okay, so you know that when the temperature is unchanging, okay, that means thermal equilibrium sudah dicapai. Okay, you've already reached or achieved thermal equilibrium. So what is the definition of thermal equilibrium? Okay, is the first question that they will ask lah. Okay, so thermal equilibrium is a very long one. So when two objects, okay, are in thermal contact, okay, when two objects are in thermal contact, okay, heat, the heat flow, sorry, the heat, not the heat flow, the, sorry, the net heat flow is 0 and the temperature is the same. Okay, net heat flow is 0, yeah. Okay, and the temperature is the same. So you have two objects that they are touching. Okay, they are in thermal contact. For example, in this case, it will be the block and the water. The block and the water are actually touching each other, but the heat flow is the same. The net heat flow is 0. Okay, and the temperature is the same. They've already achieved the same temperature. Okay, so that is a situation where we call they are in thermal equilibrium. Okay, two objects are in thermal contact, the net heat flow is 0 and the temperature is the same. Now, some books, dia memberi ayat ini lain sikit. Is the same meaning, cuma lain cara menulis. Net heat flow is 0 or the rate of heat flow is the same. Okay, so you kind of want to remember, okay, if you want to say net, then you say 0. If you want to say rate, you say the same. Okay, it is the same thing, just different way of putting it. Okay, explain how the final temperature of the water is determined by the thermometer. So basically, how do you achieve the thermal equilibrium? Okay, so this is a 3-mark question, so I'm going to give you 3 points. I don't have enough space for all 3 points. Do I have space anywhere else? Okay, never mind. I'm just going to write here lah. Okay, number 1. Okay, the heat is the heat flows. Okay, from block M to the water. Okay, the heat flows from block M to the water, which causes the mercury in the thermometer expands. Okay, the mercury in the thermometer expands until it achieves the same temperature as the water. Okay, sorry. The second and third point is in this second sentence already. Okay. The mercury in the thermometer will expand until it achieves the same temperature as the water. Okay, so the first point is you have to talk about how the water is heated up. Okay, so the heat flows from block M into the water. That's the normal one. Okay, but at the same time, there's also heat flowing from the water into the thermometer. So the heat from the water into the thermometer will cause the mercury in the thermometer to expand. Okay, the thermometer expands and then, until it achieves the same temperature as the water. Okay, so just expand, nine, until you get this one. So give one reason why this beaker is wrapped with cotton. Okay, it is to avoid the loss of heat to the surroundings lah. Okay, to avoid the loss of heat to the surroundings. Okay, now a very popular variation of this question dan soalan yang sama tapi dia tanya dengan cara yang lain is state one assumption. Okay, whenever you see the words state one assumption, nyatakan satu andaian. Okay, whenever you're talking about heat experiment, heat situation, okay, especially with thermal equilibrium, specific heat capacity, and specific latent heat, sometimes they will ask you, state one assumption you made. Nyatakan satu andaian yang kamu lakukan dalam melaksanakan eksperimen ini, or in your explanation. So the assumption that we usually do is no heat loss to the surroundings. Okay, tiada haba yang terbebas ke persekitaran. Tiada haba yang hilang lah. Semua haba yang kamu bekalkan, itulah haba yang dibekalkan kepada air, contohnya. Okay, so there's no heat loss to the surroundings. Of course, in real life, obviously there's going to be heat loss. But at our physics level, we don't really talk about that yet. Maybe when you go to Form 6 or you go to university, okay, then you will have to take those into consideration. The higher the level of physics you go, the more you have to take into account, all the different variables there are. But at our level, we just assume that there's no heat loss because we want to learn the principle first. So please know this too, okay? Give one reason why we wrap this one with cotton, okay, to avoid the heat loss, or another one, state one assumption. Kita andaikan bahawa tiada heat loss, okay, to the surroundings. Okay, based on the given information, calculate the rise in temperature of the water. Okay, the rise in temperature is very easy. It starts at 30, goes to 50, so the answer will be 20 degrees Celsius. Ini tidak payah fikir. So air dia naik daripada 30 hingga 50. The heat absorbed by the water, if the specific heat capacity of the water is 4200 joules per kilogram per degree Celsius. Now, when they give you specific capacity, there's only one formula and only one formula only. Q equals to MC delta theta. The mass of the water is given as 0.2 kg. Okay, so we have 0.2 times 4200. The rise in temperature is 20. Okay, sudah diberi untuk kamu. So all you have to do is just put it in, and you will get 16,800 joules. Okay, now remember, all this heat, 16,800, is being transferred to the water, to the block. Okay, sorry. All the heat in the water, okay, is taken from the metal block M. So that means the amount of heat that M transferred to the water is the same as 16,800 joules. Okay, and so we can use that to calculate this one, because the change in temperature is 120, and then the thermal equilibrium temperature is 50. So we use the same formula, Q equals to MC delta theta, okay, except that Q we already know, 16,800 equals to, the mass is 0.4 kg, okay, times C. What is my delta theta? It starts at 120 degrees, goes to 50. So 120 minus 50. Okay, and then when you calculate, you will get the answer. C equals to 600 joules per kilogram per degrees Celsius. Okay, given the same unit as the one in the question. Okay, So yeah, it's a much more simple question than previously. Last time they kasi MC delta theta equals to MC delta theta, so panjang. Okay, but now they break it up for you. So they say, okay, count the water one first, and then after that, count the specific capacity of the metal block M. Okay, but the idea is this: no heat loss to the surroundings. Okay, 16,800 joules of heat in M, all transfer to water. Okay, tiada yang kehilangan. Kita andaikan itu. Now, your restaurant is asked to suggest a frying pan that can be used to cook dishes quickly and safe to use. Okay, frying pan lah. Okay, apa itu kuali penggoreng? Wow, kuali penggoreng betul. So you have all these four models: model A, model B, model C, model D. Okay, and we look at the four aspects lah. One is the body, one is the surface of the body, one is the handle, and then the shape of the handle. Okay, so again, when it comes to these kind of questions, we analyze it lah. Okay, we look at it one by one, and then we see what happens to it. Okay, let's talk about the body first. What choices do we have? We have high specific heat capacity. Okay, the body has high specific capacity. This one has low specific capacity, low specific capacity. Okay, think about the body. Do we want a high specific capacity or do we want a low specific capacity? Body, body as in, you know, the tempat kamu goreng lah. Okay, so when you think about it, I think I mentioned this in last week's class. High specific capacity means it takes a very long time to jadi panas. Low specific capacity means very faster, sangat jadi panas. Which situation is the best for the body? Obviously, it will be the low specific capacity because you want the body to be faster, hot. Kan, kalau dia lama betul mau jadi panas kan, apalah kamu mau goreng. Okay, so we want a low specific capacity body. Okay, so this is the first one. Okay, second one. Dark body surface, bright body surface, bright body surface, or dark body surface. This one quite easy lah kan, because the body surface, I don't think I've ever seen a white color. Oh, okay lah, I have lah, but you know, usually we want a dark body surface. Okay, why do we want a dark body surface? Oh, sorry. Okay, why do we want a dark body surface? Because usually dark is, you know, permukaan gelap. Dark body surface is always related to can absorb heat better. Okay, absorb heat better. Okay, or it's a penyerap haba yang lebih baik lah. Yalah, can absorb heat better lah. Okay, sorry, low specific capacity. Okay, the reason for low specific capacity is becomes hotter faster lah. Okay, so faster increase in temperature. Okay, so this is how I would do it. Okay, saya akan analyze first, then saya tulis sebabnya di tepi, then only I answer the question. You know, and you know it's in table format. Those of you that have taught for since last year, you know that I always say this: answer in table format, answer in table format. But you know, now that we're nearing the exam, we talk about, okay, let's you know, specify, let's analyze the table, you know, prepare our answer, then we just write it. Makes our job much easier. Okay, third one, the handle. Okay, handle is high specific capacity because you want a slower increase in temperature. You don't want it to get hotter faster. Okay, so handle will be slower increase in temperature. Okay, becomes hotter slower. Okay, lastly, the shape of the handle. Do we want a slim shape handle or do we want a what is the other choice? A rod shape handle. Okay, yang berbentuk, you know, just like one rod. One rod is like satu macam bentuk batang sajalah. Okay, or do you want a slim shape handle? This is not a very good. It's not a very good not very good description lah. But if I look at the picture and I see the difference between the handles, okay, I will obviously want a slim shape handle lah. Okay, I will want a slim shape handle. Why? Because it has a better grip. Okay, for me, slim shape handle will be a better grip, or you avoid from like tergelincir dari tangan lah. Because the rod shaped handle is just like one small batang only lah. Okay, it may not be able to, the grip is not better. But the slim shape handle, so dia mengikut bentuk tangan makan. Okay, so it could be better lah. I guess lah. Okay, I guess it could be better. But having seen all this, when you see all the analysis, you see that, oh, okay, D is the one that fits everything. Okay, so D is the one that fits everything. So because of that, we will formulate our answer according to D lah. Okay, the body of this one, the dark body handle, this one, slim shape handle. Then we will answer the 10-mark question. Okay, now I'm not going to give you the full answer as how it should be, because I think by now, at this stage in your physics career, you should already know how to answer this 10-mark question. Okay, what you should put in, what you should not put in, but always remember it is 10 marks because, okay, each one of these is 1 mark. Okay, 1 mark, 1 mark, 1 mark, 1 mark. The reason is 1 mark, 1 mark, 1 mark, and 1 mark. So that's 8 marks. Okay, then you make the best choice. The best choice is D. Okay, 1 mark. So where is the final mark? The final mark is you write all this again. All of it. Okay, write all of it again in order to get that. Because model D has a body that has low specific capacity. It has a dark body surface. It has a handle that has high specific capacity. It has a slim shape handle. You need to mention all 4 again in order to get that final 10th mark. Okay, and I've said this to people in SA. I'm not really sure whether I told this to ST, but I will definitely not give marks if you say, because model D fits all the characteristics given above. Ini memang salah lah. Okay, saya akan tanda salah. Okay, so I will emphasize this again and again. Make sure you write all 4. Make sure you write all 4. Okay, so that you don't lose out on the 10th mark. Okay. All right, number 17. Also construct for number 9. Okay, number 9 or number 10 lah. Okay, so diagram 17 shows a cargo ship with loads of big mass moving from speed 0 to 360 kilometers per hour in 300 seconds. Okay, so the ship switches off the engine earlier before reaching the harbor. So let's say if the harbor is, if let's say the ship is here, oh no, sorry. If let's say the ship is here carrying a lot of stuff, okay, the harbor is here, usually from a distance, it will start switching off the engine. Tidak payah sudah pasang engine. Okay, so first question is what is meant by mass? Again, remember, 1 mark for explanation, 4 marks for, 1 mark for definition, 4 marks for explanation, 5 marks calculation, 10 marks make choice. Okay, section B question. 1, 4, 5, 10. Okay, so what is meant by mass? Mass is one of those definitions that, is very standard. Okay, mass is the amount of matter, okay, in an object. Okay, quantity jiran dalam satu bahan, dalam satu object. Okay, the amount of matter in an object. Now explain why the engine of the ship has to be switched off earlier before reaching the harbor. Okay, so if you know this has something to do with inertia. And so when you talk about inertia, you have to talk about mass, and you have to talk about, the relationship between mass and inertia lah. So I will probably say the mass of the ship is big. Is big, sorry, not bigger. Okay, so the ship is hard to stop because of its inertia. Then you finally say the relationship. Okay, the bigger the mass, the bigger the inertia. Okay, to give you that 3 marks. So you start off by saying the mass of the ship is big, and that makes it difficult to stop because of its inertia. What is the relationship between the mass and inertia? The bigger the mass, the bigger the inertia. Okay, that would be the relationship between these two. Okay. All right. Oh, interesting. How come I'm left with less one answer? Ada pula di sini soalan ke-11. Okay, fine. Okay, convert 360 kilometers per hour, okay, to SI unit. Okay, this will be, I'm going to give you the final answer, but I don't remember whether did I teach you the shortcut to this? Usually I don't teach the shortcut until exam only. 360 is changed to meter times 1000 divide by 60 divide by 60 lah. Okay, changing from kilometer per hour to meters per second. Okay, kilometers per hour change to meters per second. Okay, is darab dengan 1000 bahagi 60 bahagi 60. Okay, so you get 100 meters per second. Okay, calculate the acceleration of the ship in 300 seconds. So the acceleration formula is given. It's a very normal one. Okay, A equals to V minus U over T. Okay, and because this is why is it 100? Oh, okay. 0 to 360 kilometers per hour in 300 seconds. Okay, so that's why we convert the 360 to 100 meters per second. So it makes it easier lah. So it's 100 minus 0 over 300 seconds, which will give you 0.33 meters per second squared. Okay, after 300 seconds, okay, the engine of the ship is switched off. So it's going to move with the same acceleration. How far will the ship move before it completely stops? How far is an S question? Okay, so think about this. You have hold on. You have the starting one. Starting one is okay. Completely stop means is V. Okay, it's going to start with U. U equals to 100 meters per second because it's already start when it's moving 100 meters per second, then you switch off the engine. Okay, so it's 100 meters per second and it's going to decelerate lah. Okay, if the ship continues to move with the same acceleration? Wow. Okay, so the acceleration is 0.33 okay meters per second. But since it is slowing down and it's going to come to a stop, we have to put a negative 0.33 lah. Okay, because it's slowing down. So the question is, how far will the ship move? We have UVAS. Okay, so the formula will be V squared equals to U squared plus 2AS. Okay, this is the formula. Now, this is a good time for me to remind you that usually, okay, in Form 4, Chapter 2, in the Form 4, Chapter 2 questions, especially when you're talking about mass, acceleration, and inertia, it's always good to remember the 4 important formulas, which is V equals to U plus AT. Second one is V squared equals to U squared plus 2AS. The third one is S equals to, S equals to UT plus half AT squared. And then the last one is S equals to 1 over 2 U plus V times T. Okay. Now, I cannot tell you which formula is going to be given and which formula is not. Okay, so it's macam kamu punya nasib lah. But usually, for SPM questions, the formula that they give is always a formula that will help you lah. They won't give you useless formulas lah. Okay, should be they will give you a formula that you can use. So always have the formula with you, the formula list in front, to help you to kind of gauge like, okay, which formula I should use. Okay, so when you calculate this, you will get the answer S equals to 1515.515 meters. Okay, it's about 15 kilometers lah. Okay, before it finally comes to a stop. That's pretty amazing. 15 kilometers now. A very far away place for the ship to turn off the engine. That's pretty how heavy lah. That's how heavy the ship is. All right. Airline wishes to choose a suitable jet engine to be used. Jet engine is a very common question when it comes to chapter 2 in Form 4, also related to the rocket engine in a sense. Okay, but we want the aeroplane to be able to move with high speed. Okay, that's what we want. So the same thing lah, study the specifications, choose the most suitable engine. You have to convince the members of the board by giving them the reason for your choice. Okay, all very, very normal stuff. Okay, again, make the table and everything. Okay, 5 columns, yada lah. Okay, ni semua perkara biasa. Let's analyze the pictures. Okay, let's analyze the pictures, but oh, they give nothing. Okay, so hold on. Okay, so first thing is we want to have air intake, small opening, big opening, big opening. Okay, so what do we want? Do we want an air intake with a small opening or big opening? This one, obviously, we want big opening. Okay, why do we want big opening? Because kamu mau lebih banyak udara masuk. Okay, because udara itu yang diperlukan untuk membakar bahan api. Okay, one of the most fundamental things we learn in science from 1 is that you need oxygen for combustion to happen. Kamu memerlukan oksigen untuk pembakaran berlaku. Okay, so that's why we have air intake through a big opening. Okay, so more air can be sucked in. Okay, or you can also say more air for combustion lah. Okay, untuk pembakaran. Either one of these answers is fine. Okay, secondly, let's look at the blades. Do we want iron blades or titanium blades? Iron blades or titanium blades? Okay, so in this case, we will want titanium blades. Okay, why titanium over iron? Now, titanium this is a choice with many different answers. Okay, you can say that it is low density. Okay, you can say that it is light. Okay, you have lighter blades means your engine won't be so heavy lah kan, don't want that. Okay, or low rate of rusting. Dia sukar untuk berkarat because iron is very easy to berkarat lah. Or long lasting. Okay, or high melting point. Dia tidak cepat melebur. Okay, there are many answers for this. You can just choose one, you can put all 5. The most important thing is if you're going to put more than one answer, don't bercanggah. Don't say low density and then lepas tu heavy. Okay, because the moment you put jawapan bercanggah dalam ruangan yang sama, you are going to get 1 minus 1, which is 0. Okay, the wrong cancels right. This one. Okay, ruang pembakaran. Do we want a small combustion chamber or do we want a big combustion chamber? Okay, this one big combustion chamber lah. Okay, don't need to think one. Memang kena ruang pembakaran yang besar. Why do we need ruang pembakaran yang besar? Okay, so higher rate of combustion. Okay, kadar pembakaran yang lebih tinggi. Or you can say, let me see, what are the other one? Oh, okay, more combustion or more explosion, because basically jet engine works on the basis of the explosion lah. Okay, more explosion, because when there is more explosion, you get a bigger momentum. That's what we want. Okay, finally, exhaust gas, small opening or big opening. Okay, when you look at the trend, you're like, yo, saya mesti pilih S lah kan, sebab S ini 3 sudah kena pilih. And yes, you're right. Okay, you want to have a small opening. Okay, why do you want to have a small opening for the exhaust gas? Okay, so that you can have the gas, higher velocity. Okay, or higher momentum. Okay, higher velocity, higher momentum, or higher thrust force. Okay, daya tuja ke depan yang lebih besar. Because when your exhaust gas, okay, so so the idea behind this is, janganlah fikir when it is a small opening, means dia sangat kecil macam ni lah, you know. I'm just saying that compared with the front, depannya lebih besar. Belakangnya lebih kecil, tapi bukanlah sekecil macam lubang pin lah. Okay, come on, not that small, but it has to be small enough so when the exhaust dia keluar, dia akan keluar dengan laju tinggi sebab ruangannya adalah sempit. Okay, this is very logical. Okay, bila ruangan itu sempit, when the exhaust goes out, it's going to go out at a very high velocity. Kalau dia banyak ruang bahkan untuk dia keluar, then it's going to be like, okay lah, saya pelan-pelan keluar lah, so banyak ruang lagi. But when the ruang is very kecil, okay, the exhaust gas has to, you know, travel out much faster, so it's higher velocity. Okay, and when you have higher velocity gas going out from the back, you're going to produce a higher momentum. And when there's a higher momentum towards the back, it's going to produce a momentum towards the front. Dan itu yang menggerakkan kamu punya jet engine. Okay, the exhaust at the back is very small. Air goes out with a high velocity, producing a big momentum that pushes the airplane forward. If you see the airplane punya, airplane is not very good, but okay lah, fine, airplane lah. You will notice that actually the front, you notice that actually the front is slightly bigger than the back. Okay, sini dia punya kipas. Okay, this is to suck the air in lah. Okay, but you notice that the front of the engine, the airplane engine, the front is bigger than the back. Okay, front so that you can sedut lebih banyak udara, back so that dia boleh melepaskan the exhaust gas after combustion. Okay, lepas pembakaran dia akan menghasilkan gas, asap lah, okay, asap hitam. Asap itu akan terlepas dengan higher velocity. Okay, higher velocity means higher momentum. Higher momentum means faster plane. That's what we want. Okay, and this is not any other normal plane, guys. This is a jet engine, it's a jet plane. So we want it to be fast. Okay, we want it to be fast so that they can do whatever it is that they want to do lah. Okay, buat pertunjukan perarakan kemerdekaan or something similar to that. Okay. All right, I think we will end here for today. Tomorrow I will finish up the rest of the questions. I think there's only question 18 until 23. I should be able to finish it in tomorrow. There is something wrong with this paper. If you notice, so there's question 18, okay, and then 18 over here, and then 18 over here, 18 over here, then there's question 19 lah. Okay, question 19, table for question 19, yada yada. Okay. Question 20 is also this one. Okay, comes all the way. Raja 20.2 shows the incomplete electronic circuit. They give you this. Okay, they give you this. And then page 78 suddenly dia menjadi page 79. Tetapi soalannya calculate the component of the weight of the fighter jet. So there is actually a missing page. Between page 78 and page 79, there is a missing page. So I'm going to send the missing page into your class group, okay, and I will let you know what it is lah. Okay, so let's call the missing page 78A lah. Okay, we're going to call it 78A. I will send it to you in case any one of you wants to print out. But I think that we should be able to finish from question 18 all the way to question 23 tomorrow. Okay, so yeah lah, and then that will be the end of our revision session for this holidays.